Network problems are hard, especially when you add weights. When we have 2, it's easy to see which is the shortest. But when we have hundreds, thousands, or even millions of nodes, it becomes nearly impossible to calculate the shortest distance. And so, to have a look at this problem, we're going to explore adding weights into our network analysis UI. So this is what we previously made, where we can just load in a set of nodes, and they're just randomly placed. They've got no weight associated with them. They're all treated as equal, and we can just move them around, manipulate the plot so that we can shape it the way we want to, and then we can press spacebar, click on any node, click on another node, and it will calculate the path, and we can just repeat that, and we can get this nice path. However, this is super limited, and so there's a number of things we want to improve with this. Just in the way of a quick note, if you're interested in downloading any of these program files, they're available on my GitHub, Erudite code, and the link will be in the description. It's split into parts, so for episodes 2 and 3, they're here. Episode 4, which was last episode, is here, and then the episode we're currently working on will be here. But the program as we have it has a network file, a node file, these are just classes, and then a network visualization file, which is a little bit like the main.py. It runs most of the work of the file. So now we understand the structure, let's crack on with making some alterations. So the first thing we're going to do is make a new class called utilities. And actually within this file, it's not just going to be a class called utilities, but we're going to put in some useful little classes that we can make use of, such as buttons, within the main program. So within this class, it's got some really simple bits here. This is just the text associated with the button, its position, width and height, and they're all the useful sort of basic functions if you want to be able to click on it and place it. We also have a status here, and that tells us whether the button has been clicked. Is it active or not? And then we have a check click function here, which just does what it says. It checks if the button has been clicked. So within our main file, or our network UI file as I'm now calling it, we can make use of these buttons here. And here we're using the button to create node, edge, move and path. And this is just to allow us to create some nodes, create some edges, move the nodes and find a path. This menu surface, and this allows us just to place a new banner across the top in a different color, which though it doesn't functionally do anything, it just helps the user associate that area with where your controls are. Down here we use the event label, so we can pull out button, and that will tell us whether it was the left hand or the right hand button, and we can update the click type flag with that value. And then we can see here that we update our buttons, so we reset them all at the beginning to false. And then we use the state, the network state, to update only one button. And then we have a section just below that for displaying the buttons. You can see that if the button status is true, it has one color, and if not, it has another, so that we can see which button is clicked. And then we just split that surface to the screen at the right position based on the button, and we also have the text written over it, so we know what that button does. And then down here you can see that we use the mouse click flag to check. So if the mouse has been clicked, we then iterate through the buttons and using the mouse position see if the mouse was over any of those buttons. If it was, then the network state changes to that button index. Now within our network class, this is where a lot of the brains goes on, but to begin with there's just a few really simple things that I've changed. If we wanted that banner, I didn't want nodes to be placed in the menu banner, so I put a height minimum that we could use to make sure that nodes can't be placed there. So I've got the states basically set up where 0, 1, 2 and 3 equals adding a node, adding an edge, editing or moving a node and finding a path. So if we're in the state 0 and we've got a mouse click and the mouse position is in the allowed domain, so it's below that menu banner, then we can move to our add or remove node function, which we'll have a look at in a second. And the same goes for the edges. We have those same checks and we can go to an add or remove edges function. I put this little function here called check if node selected, and that's only because so often you're doing this check to find out if the mouse, when it's clicked, is over a node. So I just wrote a small function here which basically does that. Further down in our class network, we have that add or remove node and add or remove edge. Now these are actually relatively simple, and I'm not going to dwell on them a lot, so you can pause it if you want to read through them, but there's a couple of little details I want to pull out. Firstly, if you've clicked with the right mouse button, then we need to check through, remove any connections to that node, and then delete the node. And it's really important that we do this remove edge from connections function as well. And we'll just have a quick look at that in a second. And then in the add or remove edges, you can see it's super simple. They mirror each other. If the click type was left, then we're adding an edge to connections. And then down here, we have this remove edge from connections. And you can see that all it does is it checks first if the node label is already in the connections of the node we're wanting to add it to. If it is, we remove it. If it's not there, there's nothing to remove, and so we don't do anything. And then you can see to add them, it's just the reverse of this. We check that it's not there already, and if it's not there, then we append it. So let's see what that looks like. It's really cool. And so here we have our new setup, and it's super easy. You can see I've got the node button selected at the minute, and then if I go to edge, I can just add an edge, like so. Now these don't have any weights associated yet, but we're going to add that. And you can see that just as before, we can move things around, and I'm just using the left click at the minute. So if I come in here, and we can just show that you can also use the path, so we can place path here, and there you go. You're able to find a path between these nodes. And if we go back to move, all works nicely. You can selectively remove an edge. So if I right click here, that edge will go. We'll add that back in. And then we can also delete nodes with a left click as well. So you can see how this very, very quickly now you can create quite fun and complex networks that you can test and experiment with. The next stage that we want to have a look at is going to be adding weights to these lines so that you can both see a weight but then also edit that weight. In order to begin adding weights, we need to actually have a place to store them. And so within our class node, I've just created this dictionary, which basically has a format of a node and then a weight. So we can see the node that it's connected to and the weight of that connection. Now what we can do is make use of this within our class network so that when we remove an edge from the connections, we can go and find the related weight in that weights dictionary and also remove that. And of course we can, when we're adding an edge to a connection, we can make sure we add in that weight. Now initially these will all be 0. So within our class utilities file, we're going to add a new class called edge label. And this is exactly what it says in the tin. It will basically be a label for the edges. And you can see it's got the usual sort of width, height, and position. It's got a weight associated with it, but that's just for its text label. And it has the nodes that it's between. It also has an editable state so that you can decide whether you can edit it or not, and we'll work that out by clicking on it, which is why it also has this check click function at the bottom. Now we also have an update which allows us to update the position, because obviously you can drag things around and we don't want the label to stay where it was when it was first initialized. It needs to move too. And we need to be able to update the weight so that when you change the weight within that dictionary, it will automatically update on the label. Now within the class network, we need to start using some of these. So we've got to import our edge label, and we want to have a place just to store these. It'll just be a linked list of edge labels, which will populate with them. And here you can see that even though we don't have any labels at the minute, when we're cycling our update, we want to reset all the editable flags to false whenever the mouse is clicked, because what we don't want is two editable at the same time. So basically when the mouse is clicked, it automatically sets all of them to false, so nothing can be edited anymore. It's also a way of sort of clicking off them once you're finished. And Then if it happens to later on check that that mouse was actually over a label, it will make that label editable. A little bit further down, we're going to have this bit of code here where we want to check if the label is selected, and we're only going to do that in state 1, so when we're adding edges. So basically when you're in the edge tool, you can add an edge and you can change its weight, and they're being updated frame by frame. And here we can see that we've got some interesting functions such as add edge label, and you can see that along here basically all it's doing is checking if a label exists for a node or a node-node connection, and if it doesn't, then we'll create that label. And these are just some default values I selected which give a pretty good hitbox for clicking on the label. And you can see that when we do an update, we need the self nodes within that edge label to do the update. And the remove edge label is also pretty simple. This is for both adding one and cleaning one up when we're managing the edge connections. So this will be part of the add or remove edge function that we've already had a look at. And down here, we've got this interesting little bit going on where we can update the edge weight. And this is because primarily I didn't want it to happen in the main file or the UI file. So what happens is when we have a weight change, that gets passed to this function, and then we fly through the labels very quickly, finding which one is editable. When we've found which one is editable, we get the nodes out of it. We change the label editable state to false because it's all finished now, and then we use those node positions from the label to update both nodes either way the weight of that path. So then when the label carries out its update, it will pull the right weight back. You only see a change once you click if that label has been written to the node dictionary. So then we're going to have to use these within the UI, and there was just something I wanted to do quickly because I use this in a lot of other programs with Pygame, and it's a quick function to display text. I'm not going to go through it in any detail, but you can just see how it gets rid of that rather verbose method of having to declare a surface every time, set up the rectangle and then blit it. And then below that, I created a show weights, weight edit and store weight variables, which allow us to choose whether we even want to see the weights. The weight edit, well, that is clear. It's telling you whether we want to edit any of the weights, and that allows us to either look at the keyboard or not, so we'll just ignore keyboard entries otherwise. And a store weight, which is a temporary place where we hold the string that is the new weight as the user writes it. And then you can see how we use these. So if we have a key down, so a key is pressed on the keyboard, if weight isn't set up, so weight edit isn't set up, we actually check to see if there's any labels that are editable. If that's true, then weight edit becomes true and we start to store any digit presses in the store weight. Then if the mouse is clicked, weight edit becomes false. The store weight is passed to that function in the network file where we could update the weight by passing it back to the nodes, and then store weight is set to an empty string again. And then down in the display section of the while loop, we basically have the if show weights is true, we show the weights. We draw a text that has the label, and if we're editing it, it's a different color. I just thought it'd be nice to have like a red one when we're editing it, and then when we've pressed and it's been accepted and everything gone through, we'll have a nice green label. So let's have a look at this new and improved network UI. And so here it is. Now it doesn't look different at all now, but if I place a few nodes and I add an edge to them, there we go. You can see that a label is automatically being added. We can drag this around and you can see that the labels are moving around with them. And if we click on the edge, we can then start to type 345. If I now click away, it's been accepted. So we can put 200, been accepted, and then we can put maybe 40 in this one. And if I add an extra node now, you can see a problem. This edge value here to be 1000, and I ask it to calculate the path between 4 and 1, you can see it's taken no account of the weights of these paths. And that's because at the minute we're using a simple BFS algorithm to work out our path, and I really like that. I don't want to get rid of this, but I want us now to have a new button up here which will enable us to calculate the path with the shortest distance. So that's where we're going to go with this. In the next video we're going to look at that algorithm, we're going to see how we can cope with these weights and the complexity that they add, and I just hope you enjoyed this bit of a project. We're able to make some really quite complex things now, and to be quite frank, you can build almost any network you want to. And as we learn more things about networks, we'll add tools to this program that we can use to assess and analyze our networks. Thank you so much for watching. I've been trying to do something a bit new with my editing and video layout. I hope you've enjoyed, and if you have, can you give it a thumbs up or tell me what you liked or didn't like in the comments? That will really help me improve my videos. Anyway, thanks so much for watching, and I look forward to seeing you in the next one. Bye!